This video is on whether it's better to solder from above or solder from below. I've had a lot of comments lately saying that I'm doing it wrong because I'm soldering from above. So let's take a look at that. Let's see which one melts the solder faster, because that's a good indicator. I've got a timer over here, and produces the better joint. Okay, let's get started. Soldering from below. Same, heat the iron, add some solder to the tip, touch, and begin soldering. Add some more. Add some more. Okay, now it's beginning to melt on the top. And I'm using a lot more solder. And there we go. Soldering from above. Pre-warm the soldering iron. And add some to the tip. And go. And it's already starting to melt, whatever that time is. Okay, soldering from above. Here's a direct comparison of the two results. I marked this with D for conduction, so this was the direct heat transferring, and this one is from below, so this will have convection. As we saw, the time for the convection from underneath was longer than from above. Now why would that be? I mean, obviously this one has heat from below and it has heat from direct conduction, so you would think that this would solder faster, and I think that's what people are thinking, is that with the convection it should melt faster, you should get a more efficient joint. But I think there's some other things going on. Let's take a look at that. There's three ways for heat to enter the workpiece. One of them is radiating from the soldering iron, like infrared light, and that's probably not going to be a lot, and it wouldn't matter whether I was on top or on the bottom. The radiated energy would be the same, so we'll ignore that one. Then there's conduction, which is where you actually touch the piece, and the heat transfers directly from the soldering iron into the workpiece. And the last one is convection, and that's like a convection oven or whatever, where the hot air rising from the soldering iron adds heat to the workpiece. And obviously if you're above, convection isn't going to help. It's going to move any heat away. However, if you're underneath, heat from the soldering iron, convection will help the conduction heat the piece, and at least I think that's the theory that they're going on. So with convection, one of the issues is that when the hot air is rising, it's also sucking in cool air along with the hot air. So yes, you're getting hot air rising, but it's also bringing cold air along with it, which my guess is cancels any benefit from the convection. So that doesn't help. Another issue with convection is, and let me show you this up close. So everyone agrees that you should add solder to make a good physical connection between the workpiece and the soldering iron. And when you solder from underneath and you add solder like this, you can see what's happening. See, the solder is running down here. I'm losing that good connection. The solder is running away. So when I solder from underneath, my conduction solder, if you will, to make a good connection, runs away. Now there is a benefit. As I'm soldering from here, any excess solder is running down into the soldering iron and carrying away from the joint. So if I put in too much solder in the joint, it carries it away. But that's also why I used more solder from underneath than I did above to make the same joint. So yeah, I'm wasting solder and taking longer. Here we have the soldering iron tipped down, and as you'll be able to see, when I add solder, add that wetting solder to the tip to form a good physical connection between the soldering iron and the workpiece. You'll notice that drip goes down to the bottom. Gravity helps me. It helps hold the solder against the workpiece, and I get a good physical connection, and I get a lot of good heat transfer from the soldering iron to the workpiece. So when the soldering iron is tipped down like this, gravity is helping me, and when I tip it backwards, as you saw, the drip runs away from the tip, and I do not get as good a physical connection between the workpiece and soldering iron. And as you've seen for yourself today, soldering from above is faster, requires less solder. You're not going to drip solder on yourself as often. Can you see this scar on my hand? It's about the size of a dime. That's what happens when you put your hand underneath liquid solder and it drips on you. And one more word here from a very well-known company in soldering, from their brochure. They show a right and wrong way to solder, where you're touching the solder to the tip and where you're touching the solder to the workpiece, but in both cases, they're soldering from above. Well, that's it for today. Be sure to always use proper safety precautions when soldering. Hope you found this useful and interesting.